The next portion in periodicity is the chemical behavior of the periodic element. In inorganic section of the A-levels, we already discussed that group 3 elements, period 3 elements, then as well as group 2 elements, group 17 elements, and nitrogen and sulfur. This all complete package or complete bundle of chapters, about 4, give you to the MCQs of about 10 marks and also 20 marks theory portion. The first lecture of periodicity and period 3 element about the physical properties. And now today we are going to discuss the chemical properties of period 3 element. We are just interested on the period 3 elements, nitrogen to chlorine. Sorry, sodium to chlorine. The all elements of the period 3, which is starting from sodium, then magnesium, aluminum, silicon, phosphorus, and chlorine. They all elements separately react first with oxygen, then separately react with water if any reaction is take place. Then the compound formed and separately also react with chlorine. There are the 3 chemical reaction of period 3 elements with oxygen, water, and chlorine. Then next chemical properties or next chemical behavior or reaction is when the oxides form. For example, sodium react with oxygen and form sodium oxide. Similarly, magnesium react with oxygen and form magnesium oxide. Likewise, other. They also separately dissolve or react with water. Either they are dissolved in water or maybe react in water or remain inert in water. It's all possible. The first scheme is the element reaction with oxygen first, with water second, with chlorine third. Then the product of oxide and the product of chloride separately add into the water. Separately add into water. For example, if we add phosphorus chloride, PCl5. So does any reaction occur? If yes, so what is the type of reaction? What's the chemical equation? And so on. So similarly, this chemical behavior or chemical properties pattern in the 5 classification: element with oxygen, element with water, element reaction with chlorine, and then product formed with the reaction with oxygen, product formed when the reaction occurs of the group period 3 elements with water, separately add into water. If any reaction, any changes occur, so what is the change, what is the approximate pH in case sometime, and chemical nature, color, and similar for the chlorine. So first is the equations of when the reaction of period 3 element with oxygen. If we come sodium, magnesium, aluminum, silicon, phosphorus, chlorine is not much interested in syllabus, and separately react with oxygen, they all form oxides. They all form oxide according to the period position. Sodium in the group position, sodium in a group 1, so sodium oxide in this formation. Similarly, magnesium oxide, similarly aluminum oxide, silicon oxide, phosphorus oxide. Phosphorus may be written as P4O10 as well as P2O5 because phosphorus in group 5 and is group 2. So group 6, 2 unpaired or valence electron, 5 electrons crossing this one. This may be occur in the P2O5 or dimerize. It means that the 2 units combine together. Here is the first scenario where the chemical equations. When sodium reaction with oxygen, this is the chemical equation. So all AS student must have to be remember the equation, first part, and then any observation, any color change will happen during the reaction. So here's a list of the or summary of the color changes. First, what happens when you place a sodium, which is a gray, silvery gray soft metal, and place in the where the oxygen is present, they rapidly react with oxygen burned with a yellow bright flame. The first observation when sodium is burned is produced bright yellow flame. The main product when the sodium burned limited amount oxygen, white solid sodium oxide is formed. The main product when the sodium burned in limited oxygen. If in case of the limited amount of oxygen is present, you say the white solid sodium oxide is formed. Irrespect to the product, the nature of the and the color, mostly the sodium formed with the oxide, in the case of the oxide, is white in color. So you may write that the two observation. First, color, when the sodium burn is produced bright yellow flame, and second is white solid of the sodium oxide. These two properties or these two observations you may notice during the reaction. The next is when the reaction of magnesium occur with oxygen. Similarly, magnesium also react not as much vigorously as sodium, because sodium is group 1 and very reactive metal. Likewise, other is not as much as reactive. Magnesium also react vigorously when heated in oxygen. The difference is become when the heated in oxygen, not room temperature. While sodium reacted vigorously at room temperature or normal circumstances. For magnesium oxide, aluminum is protected layer of the magnesium oxide, but powdered aluminum. If you react with aluminum rod with oxygen, so there is almost no reaction happening. Although aluminum is more reactive, but when you put the aluminum powder, this is because aluminum form the protective oxide layer at the surface. Means that aluminum is a very reactive metal. As soon as aluminum is formed, they form the very protective layer on its surface, like a plastic coating. Suppose this is a bar of the aluminum initially extracted, electrified, or manufactured. Then this layer is eventually come into the contact with oxygen, form the oxide layer, which is very protective, and the no more reaction is occurred like a plastic coating around the book, which prevent the moisture and dirt from the actual course of actual pages of your books to become a dirty. Similarly, aluminum is also protected with a layer of oxides and form aluminum oxide, which is very protective layer and does not contribute in any chemical reaction in normal circumstances. As we go to the aluminum and make aluminum powder, so the reaction is happen. So that's why it's marked as a aluminum powder. When aluminum becomes powder, does react with. In both cases, this is like third equation, fourth equation. In both cases, the observation, definitely there is a no observation is present. In case of the aluminum, they're both metal burned with a bright flames, both burned with a bright flame and produce a white solid. In both cases, first observation is bright flame, and the second is white solids. And silicon react very slowly. Silicon oxide produce silicon oxide. This is also white solid. The only observation. Phosphorus react vigorously with oxygen. Again, yellow or white flame is seen. Both is okay. And also the produced white clouds of the white phosphorus oxide are produced because they are the covalent compound. So they are not much higher temperature. So because of the exothermic nature of the reaction, they are easily become into the sublime form and white powder. Sulfur is also react with one more metal which I'm escaping is a sulfur, phosphorus, sulfur, and then chlorine. Sulfur ignite and burn gently with blue flame. Generally, the color of the flame you observe when the domestic gas burn in your stove is because of the presence of the some sulfur or sulfur compound. When the sulfur is burned, it's produced sulfur dioxide, which is formula SO2. Sulfur further oxidizes into trioxide, but this oxide is normally not easily formed until unless you provide a very harsh condition to the reaction which may happen or occur. There's series of equation, first for the sodium, then magnesium, aluminum, silicon, phosphorus, and sulfur. So all together, 5 equation. Chlorine also form oxide, but chlorine oxides are not much interested in syllabus. That's why they are generally skip this one. The second category, when the reactions of pH3 element with chlorine, they are readily react with the chlorine as well and produce chloride. And formula of chloride again on the basis of the position in group means group 1 NaCl, group 2 MgCl2, group 3 AlCl3, which converted into AlCl6, Al2Cl6. What happened we discuss later on. Silicon also react as silicon in the group 4. Silicon in group 4. So silicon also form the SiCl4 according to the outermost electron or group number. Phosphorus PCl5. They all react with chlorine and form the chlorides according to the group position. Likewise, you write the formula in this case like this one. Here is the group number. If you are in the group 1, so put 1. Group 2, then put 2. Group 3, then put 3. Group 4, put 4. In case of the group 3, this formula is correct. But actually, aluminum chloride readily form dimerize, means that the two particles of the aluminum chloride combine together and form Al2Cl6. So initial composition is AlCl3 is okay. And silicon oxide, SiCl4, then similarly phosphorus chloride, silicon chloride and phosphorus chloride, they form PCl5. In this many cases, they are the certain reaction which also produce some observation as well. The chloride of the metals, sodium, magnesium, aluminum, and also for the silicon, they all are solid at room temperature and likely to be a white solid. But phosphorus is a non-metal. Silicon is considered to be a non-metal, but due to the silicon chloride is liquid at room temperature. Silicon oxide is solid. Silicon is non-metal and its form chloride is become a liquid at room temperature, means that the bonding nature will be covalent, likely to be because of low melting and boiling point, and PCl5 is also non-metal combination, so nature of bonding is likely to be a covalent. And again 5 set of equation with chlorine. In each case, the one observation which always present is the disappearance of the chlorine, which is the greenish gas. So in all cases, you must write a single observation at least, which is the color change greenish to colorless, because the disappearance of the chlorine during the reaction or decrease in amount of chlorine during the reaction. The other reaction, this is a second form in which we are react different elements with period 3 elements. We discussed already period 3 elements with oxygen, period 3 element with chlorine, period 3 element with water. If anything happens with water, then product of oxygen, which is called period 3 oxides. Likewise, I write the formula in this form, X and Y. And similarly, period 3 chloride, like the formula in this form. If anything happened when this one added to the water, they also discussed. The third part, period 3 element directly react with water. So many of the period 3 elements, other than magnesium and sodium, they are not very reactive towards water. Aluminum definitely because of the protective layer. Another element due to the non-metallic behavior. When the sodium incidentally or put into the cold water, the eventually reaction is very vigorous and sodium float on the surface, which is one observation, and given off hydrogen gas, bubble of gas as other, and get smaller and smaller because it's converted into sodium hydroxide, means the solution becomes strongly alkaline because of the presence of OH ion. And also the observation which is producing the yellow flame, burn with a yellow flame on the surface of water, burn with yellow flame on the surface of water. So here is a picture which clearly seen that the sodium metal put into the jar or cap containing some water, they readily or vigorously react and produce the yellow flame. and as well as the solution becomes strongly alkaline. This is a reaction equation when sodium react with water. By contrast, or by considering the other element, magnesium is not much very reactive towards cold water. It may react very slightly with water in the cold condition, but reaction is certainly take place at very high rate as the reaction is with cold rather than cold water with a hot water or heated magnesium. So then two equation. In case of first cold water, which is marked as a water in the liquid state, room condition, they produce hydrogen gas as well, like sodium hydroxide as well as magnesium hydroxide. But this reaction is very slow. If you speed up the chemical reaction, you either heat the water or magnesium, so the reaction becomes faster. The end product is also changed, which becomes magnesium oxide and hydrogen gas. So one product remains same, another product will become change as the temperature changes. Likewise, the other element, if you think that this aluminum, silicon, phosphorus, sulfur, they are not affinate with water or does not show any significant reaction with water at room temperature or even at the high temperature because of the very protective oxide layer, and there's not any possible reaction or the very high already bonding formation between the particles, so water cannot easily interact with these elements. So fortunately we have less equation in case of the water, only with sodium, and in case of magnesium you have two equation, cold as well as heated condition. Cold magnesium with cold water produce magnesium hydroxide and hydrogen. Magnesium with hot water produce magnesium oxide and hydrogen gas. The next part, when these compounds means that the element react with oxygen, chlorine or water, they produce different nature of compound. For example, we discuss oxides. They all react with water to form the different nature of oxide. Here is the nature of oxide is tabled in the table number 10.8. So different oxides other than chlorine, because we are not interested in chlorine, as well as sulfur trioxide is okay, but sulfur trioxide is normally does not form at the room temperature and pressure until you provide a very hard conditions. So we have only 5 oxides: sodium, magnesium, aluminum, silicon, phosphorus and sulfur. As per group number, sodium +1, +2, +3, +4, +5, and sulfur +6 because in the group 6, but likely the oxidation state is 4 because sulfur contain outermost 2 unpaired electron and they are double bonded with each side of oxygen. They become +4. Considering that this nature of the compound is covalent. So covalent nature, there's a no complete transfer of electron, but we always put the charge of more negative to the more electronegative element, which is more right and more extreme top of the periodic table. For example, for the period 2 elements are more electronegative than period 3. And similarly, period 7 element, group 7 elements are more electronegative than group 6 element. So oxygen mark as a -2, another is marked as a plus after the calculating or just putting the group number. If we discuss the nature of the oxide, metal, non-metal, ionic, covalent, 3 are ionics and 3 are covalent. And then structure: giant ionic lattice, giant covalent lattice, simple covalent lattice, simple covalent lattice. Because silicon is one of the elements which continuously form a structure to form joint tetrahedral fashion to form the giant covalent structure. Phosphorus, simple molecular. Compound which is extremely ionic in nature, like extremely ionic in nature, magnesium and sodium, and extremely covalent in nature, and in between the compound which is very inert towards water. These compounds, when you try to put sodium oxide or magnesium oxide in water, they easily dissolve. But these two nature of the compound, aluminum and silicon, they does not dissolve in water. Some compound of the oxide, we are discussing that the period 3 oxide properties in term of the bonding, in term of the affinity with water, reaction with water. The the first part is nature of bonding. Ionic, 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 covalent, covalent, covalent. Second, giant ionic structure. Giant ionic, giant ionic, giant ionic, giant covalent, simple covalent because of the low melting point, simple covalent. You have to be remembered. Simple covalent. Then solubility, water soluble, insoluble, insoluble, soluble, soluble. We mark as a soluble. The term soluble is not much appropriate. That much chemical term is rather than the soluble react. They generally react with water. The first part is that when the ionic compound dissolve in water, so ionic lattice readily break due to the formation of ion dipole with water. Water is a covalent molecule. They readily hydrate or surrounded by cations or similarly anions. So ionic bonding breakup. And this O negative ions, which is called oxide ion, this oxide ion actually hydrolyze or react with water to produce hydroxides. Hydroxides. The reaction is that when the ionic lattices break, when the compound is dissolved in water, the first part, then this compound readily hydrolyzes with water to produce OH ion. And the presence of OH ion means the solution becomes more alkaline. As the solubility of OH increases, as the solubility of hydroxide increases, the solution becomes more strong alkaline. And the solubility trend among group 1 hydroxide are always more soluble than group 2 hydroxide in the same period. And then group 2, within group 2 hydroxide, which is discussed later on group 2, but I'm just go through quickly. Group 2 hydroxide solubility increases down the group. Group 2 hydroxide solubility increases down the group. So you have to be remember the trend when the oxide, which is ionic in nature, dissolve in water. The first step is that the ionic lattices break and the ions, cation and anions enter into the solution, forming cations and anions, which is hydrated, especially O negative oxide strongly hydrate to produce OH ions, which is strongly produce alkaline solution. And the next part is predicting the pH. More soluble hydroxide, more higher the pH. And the group 1 hydroxide are more soluble compared to the group 2. Group 1 hydroxides are more soluble compared to the group 2 hydroxide. So group 1 hydroxide readily dissolve and produce more OH ion than other hydroxide like group 2 hydroxide. So all the trend now, in this case of the non-metal, we go to the non-metal as well. The first is about to the metallic part. So two metals, magnesium oxide and sodium oxide, they are water soluble. They readily dissolve in water to produce OH ions. More soluble the OH ion, more stronger the alkali, higher the pH. And group 1 hydroxide are more soluble compared to the group 2 within same period. That's why sodium hydroxide mark the pH around 13, 14, and this pH is likely to 10 or 11, which is much lower. And similarly, the other trend is that we generally use the term as metal oxides, basic or alkaline in nature, basic in nature. If water soluble, we also called the alkali. Metal oxides are water. If metal oxides water soluble, we call the alkali or otherwise base. So if you put the another property after bonding and structure, these two metal oxides are water soluble. They are base. We use the broader term base. Metal oxide basic in nature. Non-metal oxide are acidic in nature. We intentionally skip chlorine because of the out of syllabus and not interested examiner in the asking the question about chlorine. Phosphorus and sulfur oxides are non-metal oxides, so definitely acidic in nature. One is basic, second is acidic. Silicon is also included in this way as well. But aluminium is also metal, but aluminium does not show metallic behavior alone. They show metallic as well as non-metallic behavior. That's why we term as amphoteric oxide. So first two oxides, oxide, not metal. Sodium oxide, magnesium oxide, basic. Aluminium oxide, amphoteric, means act as acid as well as base. Act as acid plus base as well. And last three non-metal oxide, only acidic in nature. If we claim, like suppose sodium and magnesium are acidic in are basic in nature because of the metal oxide, so we must go reaction with acid. If you justified any substance as a act as acid, so you must test with a counter. And counter of acid, we all know the counter of more acids are base. If we claim these two are basic in nature, so we must go react with acid. So if you summarize that, first is the solubility. You have to remember sodium, magnesium dissolve in water, produce oxide sign, which readily hydrolyze to produce hydroxide ions, and more soluble the hydroxide, more stronger the alkali and higher the pH. Aluminium is what? Aluminium, silicon, water is soluble. Phosphorus, sulfur oxide, water soluble, produce react different certain reaction. We discuss later on, right? Here as well. And then next is about the conformation of the property. If you claim this one are basic, acidic and basic behavior, metal oxide, acidic in nature, non-metal oxide, basic in non-metal oxide. Metal oxides are basic in nature and non-metal oxides are acidic in nature, except aluminum, which is metal oxide from metal oxide, metal and aluminum oxide, definitely metal oxide, but does not show the only metallic oxide property, which is basic. It shows as well as acidic properties as well. So now the next is a series of equation. If you claim that sodium oxide is basic, so you go react with the sodium oxide with any acid. So if you react with HCl, it's produce NaCl and water. For balancing purpose, you put here too as well as here. If you also claim that the magnesium oxide is acidic, so you react, magnesium oxide is basic, so react with acid, is produce magnesium chloride and water. If you claim aluminum oxide is amphoteric, so your list will become slightly increased. You show the reaction with acid like HCl, AlCl3 or A2Cl6, both correct, and water. For balancing purpose, 3 here. So this sort of equations, but you also, because aluminum does not show only reaction with acid, this is the problem. Aluminum does not show only reaction with metal. It's also show the reaction with aluminum oxide, not only the show reaction with the acid, it's also show reaction with base as well. So in case of the aluminum, when the aluminum oxide react with acid as well as react with base, so this is a more important equation, most important equation, which examiner asks multiple time in exams, which is the aluminum oxide reaction with hot alkali, with reaction with hot alkaline condition to produce the sodium salt of the aluminum oxide with sodium aluminum hydroxide. So in case of the aluminum oxide, which is amphoteric in nature, so you have to support equation with two reagents, acid, maybe HCl, H2SO4, or likewise other any acid acceptable, and reaction with base, likely to use only the strong base, which is sodium hydroxide in hot condition. This salt is called double salt or sometimes called complex salts. So you just have to be remember the formula sodium aluminum hydrate. It's also mentioned the name as sodium hydroxide aluminate, but you don't like to be remember this complex name. So you just remember the composition. This equation is tough to balance, so that's why examiner gives us some leniency to use the water as a reactant because they're all reaction in aqueous medium. So sodium react with the aluminum to produce a sodium hydroxide react with aluminum oxide in the presence of water. Definitely aqueous solution sodium aluminum hydroxide. These two equations combine together to show the nature of the aluminum oxide, which is amphoteric in nature. because we use the two different reagent, and aluminum oxide show the in all cases positive result in both way. Silicon, phosphorus, and chlorine, silicon, phosphorus, and sulfur all are the non-metal oxide which is acidic in nature. And similarly, silicon oxide is not water soluble. So we are not supporting any equation which showed silicon oxide dissolve in water. Nothing will be happening because silicon oxide is not dissolving in water. So if it does not dissolve in water, no possible reaction is occur. So we are going to react with sodium hydroxide because this one is acid. So reaction with base produce sodium silicate, which is a raw form of the glass. And the next reaction is reaction of phosphorus oxide and sulfur oxide with water. Phosphorus and sulfur oxide, which is covalent in nature first, and also simple covalent lattice, means that this lattice is easily break in water. When the lattice easily break in water, so the reaction with water can also be happening. When covalent react compounds, whenever the covalent compound react with water, the term of reaction is used as hydrolysis. So you say that the reaction is hydrolyzed reaction. Hydrolysis is occur when the metal oxides, when non-metal oxide like non-metal simple molecular oxides, which having the structure of simple molecular lattice, react with water. The type of reaction is called hydrolysis. Water itself break as well as the compound which undergo the reaction with water is also break or disintegrate. Here is an example: phosphorus oxide react with water. So water is also disintegrate and phosphorus oxide is break and produce the phosphorus 5 acid, phosphoric acid, and sulfur. This equation is enough. When you sulfur oxide, discuss the sulfur oxide, this react with water to produce sulfurous or sulfur 4 acid. In this case, similarly, more H plus ion, more strong acid, and more strong acid ultimately lower the pH. In case of the phosphoric acid, produce the more H plus ion because it contains 3H plus, here is a 2H plus ion. And the other way, this is not too much good chemistry. The correct is that the phosphorus oxide is phosphoric acid completely dissociate, and this one is only partially dissociate. So more H plus ion, more stronger acid, and we likely to assign the pH around 2, and we assign the pH around 5 or 4. In case of the sulfur dioxide dissolved in water to produce sulfurous acid, not sulfur trioxide. This is also strong acid, which also mark the pH around 1 and 2. This correct. Both sulfur oxide are present and you have dissolved in water. The key point is that when the compound is covalent and its structure is simple covalent, compound is covalent and its structure is simple covalent, so reaction with water readily occur, and the type of reaction is called hydrolysis. In both cases of phosphorus oxide and sulfur oxide, either tri or dioxide, they readily produce a solution which contains H plus ion. And more presence of H plus ion, more stronger the acid, means completely dissociate is from. Here is a summary table which show the acidic nature, basic nature, and amphoteric nature. Basic, amphoteric, then non-metal, acidic. Ionic, giant ionic, covalent, simple molecular, they also assign. If you mark aluminum oxide or rank aluminum oxide as an amphoteric, so you must have to be show the two equations: reaction with acid as well as base or alkali. This one is not water soluble, so you go only just to the silicon oxide is not water soluble. So silicon oxide is not water soluble, so you have to go only the base, sodium hydroxide. Similarly, for case of the phosphorus or sulfur dioxide, which is water soluble because of the simple molecular structure, they are readily react with water after the break. The covalent bond nature is disintegrated in water, react readily to produce the strong acidic solution as well. Here is some diagram to show the nature of the bonding, how the nature of the bonding is defined, like simple molecular, giant molecular, and other structures, ionic structure. In case we discuss the hydroxide, we discuss oxide. This is the main equation when oxide react with OH. When oxide dissolve in water, and if oxide is dissolved in water, capable to dissolve in water like ionic oxide, Aluminum oxide is not readily dissolved in water because of high lattice energy. Magnesium oxide and sodium oxide easily dissolve in water to produce O negative ions. And this O negative ion react with water to hydroxide. This is the ionic equation when the metal oxides dissolving in water first and then react with water. The actual process is reaction with water, not simply dissolve in water. And the next part, the reaction with chloride of period 3 elements. So period 3 elements similarly react, all period 3 element chloride form. We are not interested in the chloride or sulfur. So 5 chloride. The chloride are again ionic, covalent or simple covalent molecular nature. They all may react or dissolve in water only. Again, here is a summary table, have to be remembered here. This table indicates what happened. Nature of bonding ionic, nature of bonding ionic, nature of bonding covalent, 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 covalent. This is not giant ionic, simple molecular, simple molecular, simple molecular. The structure which is a giant ionic and bonding ionic likely to just dissolve in water or no significant impact on pH. No significant impact on pH. There is an impact of 0.5, but this does not consider too much effect. And all oxides with a simple molecular in nature, they are readily react with water. They are all chloride with a simple covalent in structure, readily react with water to produce the acidic solution. All acidic solution and strong acidic solution, likely slightly less acidic is aluminum chloride. Otherwise, all are the very strong acid, silicon, phosphorus, aluminum. All are the strong acid, but classify slightly less aluminum chloride. Ionic just dissolve in water. So here is the equation. When ionic compound dissolve in water, ionic lattice break, sodium ion separated and chloride ion separated as the mark as an enthalpy change of solution or just dissolving the compound in water. In case of the aluminum oxide, there is a slightly complex condition in aluminum chloride. Sorry, in case of aluminum chloride, there is slightly complex condition. First of all, aluminum chloride exists in the dimerized form, means Al2Cl6. This compound slowly breaking in water slowly and gradually produce Al3 and Cl minus. The first existence, this existence convert first in this form and then in this form in aqueous solution. This aluminum ion, which is hydrated, means water particles surrounded. As the water particles surrounded around the aluminum, so we write the equation of the aluminum in this way. This is the same as the aqueous aluminum we write here. These both two forms are same. Because of the high charge nature, they try to compensate the charge and breaking up the water means hydrolyze or release the H plus ion. So H plus ion gradually releases, leaving behind, here is a 6 water. Then after 5, this contain 5 water and 1 OH and releasing of that. This means that the solution becomes gradually acidic due to the release of the H plus ion. Silicon and phosphorus, this is another very important equation and examiner multiple time asks. Chloride dissolve in water, rapid reaction. In both cases, fumes, white steamy fumes is observation, like in this picture. Like in this picture, you see the white steamy fume because of the HCl vapors. And presence of the both strong acid, the pH becomes highly acidic. You may slightly differentiate as well. In case of the presence of 2 acid, you mark 1 around, and this one is also the strong acid, but only 1 to, so you can mark as a 2. And the difference is silicon oxide, which is insoluble. When silicon chloride, which is generally liquid, colored as liquid, react with water, you have two observations. White misty fume due to presence of the HCl. Solution becomes a strong acid due to the HCl particles also dissolve in water. And the presence of silicon oxide means white PPT. In case of the phosphorus, when phosphorus chloride react with water, the observation is again acidic solution. The pH is around 1. definitely you put the pH rod or indicator, so color change toward the acidic side. And the second observation, which is HCl misty fumes. So you observe misty fumes of HCl when chloride dissolve in water. This is all about the chemical reaction or chemical properties of group 2, period 3 element. Hope so you can be understand the all terms. So it is okay and for the today class. Next time inshallah with next topic as well.